In Concept B, we're going to be focusing on metals, nonmetals, and metalloids. So you're going to be able to describe the properties of these three materials. You're going to be able to identify where they are in the periodic table. Also, then we're going to talk about topics related to something called allotopes and diatomic elements. So some properties of metals that you need to know. They're excellent conductors, not just of electricity, but also heat. They have luster, which means that they're shiny. They're also malleable and ductile. These are two important vocabulary terms that you need to know. Malleable meaning that they can be hammered or rolled into a thin sheet, and ductile meaning that they can be drawn into a thin wire. And those properties allow us to use metals for a variety of purposes. Metalloids are a mix of properties of metals and nonmetals. They're semiconductors, so they sometimes conduct like metals, and they sometimes don't like nonmetals. They have luster like metals, however, they're not malleable and ductile. They're brittle, so they tend to shatter, which is more like our nonmetals. And these are located directly along the staircase on the periodic table. Our nonmetal properties, they're insulators, which means that they're poor conductors of not just heat, but also electricity. They have a dull appearance, so they don't have any luster or shine to them, and they're brittle. So when we strike them, if we were to hammer them into a thin sheet or try and draw them into a wire, they're going to shatter when we apply pressure to them. And so where these are located on the periodic table, for the most part, all of our metals, which is the most of our elements on the periodic table, are located to the left of the staircase being right around where the green part is, except for hydrogen. Hydrogen is a nonmetal, which is why you see it in red. So we have our metals here. Along the staircase, we have our metalloids, with the exception of a couple. Our metalloids are just boron, silicon, germanium, arsenic, antimony, and tellurium. And we'll talk a little bit more about that in class tomorrow. And then our nonmetals, besides our hydrogen, are located to the right of the bold staircase on your periodic table. So metallic character, that means the degree to which an element matches the characteristics of our metals. Metals tend to lose electrons and form positive ions, so they have a low ability to gain electrons, and they tend to lose electrons easily. So elements that have those properties tend to have a high metallic character. As you go down a group, the metallic character increases, and this occurs anywhere on the periodic table, we could say. As you go across the period from left to right, the metallic character decreases, meaning that our most metallic elements are going to be in the bottom left-hand corner of our periodic table. Our non-metallic character is the degree to which an element matches the characteristics of our nonmetals. Nonmetals tend to gain electrons and form negative ions. They have a low ability to lose electrons, and they can gain electrons easily. So elements with those properties have a high metallic character. As we go down a group, the non-metallic character decreases. As we go across the period from left to right, our non-metallic character increases. So our most non-metallic characters, which that's what it should say up at the top here, non-metallic, are in our upper right-hand corner of the periodic table. All right, some other important information that you have to just know and memorize about the periodic table, and we'll talk more about in class tomorrow. You need to know the states of matter at STP, and STP is just standard temperature and pressure. It's a set temperature and pressure, and at this STP, which is on the front of your reference table, you need to know what our gases and liquids are in terms of our elements at these temperatures and pressures. Our gases are hydrogen, nitrogen, oxygen, fluorine, chlorine, and then all of group 18, the noble gases. Our liquids, we only have two. We have a metallic liquid, which is mercury, and we have a non-metallic liquid, which is bromine. All other elements are solids at STP, so you want to focus on knowing the gases and liquids, and then realizing that the rest of them are solids. Another part is that not all of our elements can exist as a single atom in nature. Diatomic elements are composed of two atoms that are bonded together because these elements cannot be found as a single atom in nature because they're unstable alone. So they pair up in order to fill their valence shells and be a more stable element. So here we have hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. There's two ways you can remember this, either the phrase horses need oats for clear brown eyes, which is the way I tend to memorize it, but there's also another helpful if you're more of a visual person, the 7-up method. Nitrogen is number 7 on the periodic table. You start there, you draw 7 to fluorine, and then down to iodine, and then you go up to include hydrogen. So you can think of the 7-up method. Lastly, allotopes is another important vocabulary term from this unit that you need to know. An allotrope is one of two or more different forms of an element in the same phase, but with different formulas and different chemical and physical properties. So these have a different arrangement of particles which cause different chemical and physical properties. So examples of carbon are diamond, graphite, coal. Diamond and graphite are pure carbon atoms. However, because of how they're bonded and arranged, they take on completely different properties. Oxygen, the same thing. We can either look at O2 or O3. O2 meaning the diatomic oxygen that we need in order to breathe, compared to ozone, which is actually damaging to our lungs. So again, different formulas, but they're both considered pure oxygen. But because of their different formulas and different arrangement of particles, they have completely different chemical and physical properties. Okay, so that's it. We'll go back over metals, nonmetals, metalloids, and then this new information about phases, allotopes, and diatomic elements tomorrow in class.